factor completely plus solve for x by factoring. Now, there's lots of different types of factoring that we're going to see. This isn't the only one, okay? There are other types of factoring that we're going to look at. Today, we have several examples to look at. 6x squared plus 30x, okay? You'll notice there are two terms there. Well, the first thing you should always do is look to see, do the terms have anything in common? Do they have a greatest common factor, okay, which we abbreviate as GCF. Well, 6 and 30, what do they have in common? Well, they have 2 in common. They have 3 in common. But are those the greatest common factors? No. Okay, hopefully you see that the greatest common factor is 6. So we're going to pull out a 6. Okay, now both terms have x in common. You'll notice one has x squared and the other has just an x. Okay, remember x squared is x times x. So yes, we can pull out just a single x from both of them. Now, what's left when we pull out a 6x? Well, when we pull out the 6x from the 6x squared, we're left with just x. When we pull out the 6x from the 30, we're left with 5. And in the middle, we still have our plus sign. Okay, so now we have factored that one. Look at the two terms, x plus 5. Is there anything more we can do with that? No. Okay, they both have 1 in common. That's our goal, to get it down to only having 1 in common. So that one is factored completely. All right, looking at example 2, 12x squared minus 20x. Again, we want to look. Do they have a greatest common factor? Yes. Okay. Hopefully you can see that they both have 4 in common, and 4 is the greatest common factor, so we can pull out a 4. And again, we have x squared in the 12x squared and an x in the with the 20. So again, we can pull out just a single x. Okay, what's left? Well, when we pull out the 4 from the 12, we're left with 3, because 4 times 3 is 12, so 3 is left. And we pulled out a single x. Pull out from the 20, we're left with a 5. There is no x because we pulled it out. Now, in the middle, we have to put our minus sign. Now, do 3x and the 5 have anything in common? No, just 1. And again, that's our goal. We want to have a common factor of just 1. So we have factored that one completely. All right, next two examples. Now, these two examples are special cases. It's just two terms. We have an x squared minus a 25, and we have the x squared minus 100. Now, x squared and 25, okay, they are perfect squares. All right, we can take the square root of x squared. What's the square root of x squared? X. We can take the square root of 25. What is the square root of 25? 5. Okay, so now in the middle, we have a minus sign. So this special case is called the difference of two squares. Again, this is a special case. So when we factor this one, we're going to create two binomials. One's going to have a minus, the other's going to have a plus. The square root of x squared is x, so we put an x in each one. And the square root of 25 is 5, so we put a 5 in each one. So x minus 5 times x plus 5. Okay, same thing with the x squared minus 100. It's a special case. Those are difference of two squares. So again, we're going to create two binomials, one with a minus, the other with a plus. Square root of x squared is x. Square root of 100 is 10. And we have factored those completely. Now, One thing I forgot to look at, and I should have started, is do the greatest common factor. You will notice that the greatest common factor, when we look at x squared minus 25 and the x squared minus 100, the GCF here, the greatest common factor, is just a 1. And pulling out a 1 isn't going to get us anywhere. Okay? So let's look at the next two examples. Now again, if I start off by looking for the GCF, okay, there's three terms here. X squared plus 6x plus 8. Okay, the GCF is 1. Pulling out a 1 isn't going to get us anywhere. Okay, it's not going to help us factor it. So we have to look at it from a different approach. Since there are three terms here, we start with the last term, 8. What we want to do is we want to look for factors of 8 that add up to the middle term, 6. Well, factors of 8, remember, are 1 times 8, 2 times 4. Well, that's not too difficult. Which two add up to 6? Well, 2 and the 4. So when we factor this one, we create two binomials, x in each one. Again, there's the lead coefficient here is 1, so we just put x in each one. And the 2 and the 4 are positive, so we're going to put plus 2 in one and plus 4 in the other. Okay, those are factored completely. Okay, the next one, factors of negative 10 that give us negative 3. Well, first of all, let's look. Negative 1 and 10, positive 1 and negative 10, 2 and negative 5, and negative 2 and positive 5. Those are factors of negative 10. But which two add up to give us negative 3? Again, hopefully you pick the 2 and the negative 5. So when we write this out, we're going to create two binomials, x in each one. Now, the 2 is a positive, so we put plus 2, and the 5 is a negative, so we put minus 5. Okay, so double check that, multiply those together, that gives us the negative 10, and add those together, it gives us the negative 3, or the minus 3. All right, now, one more step. Solve for x by factoring. Well, I picked the two that we just did. Now, you'll notice that this trinomial equals 0, and this trinomial equals 0. So we want to figure out what x will be to make that equal 0. Okay, solve for x by factoring. Well, we already know the factors. This one was, remember, x plus 2 times x plus 4. Okay, but now it equals 0. Well, what is going to make x equal 0? So take each binomial. Take the first one, x plus 2. What will make it equal 0? Okay, because remember your multiplication facts. 0 times anything is 0. So if we can make the x plus 2 be a 0, and we multiply it to whatever x plus 4 is, we're still going to get 0. Okay, well, one-step equation here. Subtract 2 from both sides. Okay, pretty obvious, I hope. X is negative 2. All right, so that is one of our solutions. Okay, well, do it for the other one. X plus 4 equals 0. Okay, hopefully that's obvious. So x would be negative 4. So those are the solutions for x. Okay, same thing with this one. We have, remember, x plus 2 and x minus 5. Again, what will make those equal 0? Well, we already did the x plus 2 up above, so we already know that that's x equals negative 2. And what will make x minus 5 equal 0? Well, hopefully you noticed that that would be 5. Okay, so x equals 5. And that's how we factor completely and solve by factoring.